We're going to start with an overview of our number system. All of the numbers we'll be dealing with are complex. They can be written in the form a plus bi. So for example, like 3 plus 5i or something. Those types of numbers. We'll describe everything we'll be working with. The complex numbers break down into two subsets. You'll have your real numbers, where there are no imaginaries, right? The b part is 0. And then you'll have, if there are the a part 0, then you have your pure imaginary. Alright, and so then we can break down our real numbers even farther. So you'll have real breaks down to rational and irrational subsets. And when you're thinking rational versus irrational, think of that word ratio. Ratio means fraction, so rational numbers are any numbers that can be written as fractions. So for example, 2/7, or maybe even -3/5. Negative numbers are fine as well. Or even 3, because 3 you could write as 3/1. So anything that you can write as a fraction, as a ratio, is rational. As opposed to irrational numbers, these are your never-ending non-repeating decimals. Never-ending non-repeating decimals that cannot be written as a fraction. Never-ending non-repeating decimals can't be written as a fraction. So like 0.932, blah blah blah, on and on forever. So famous examples are pi. Irrational goes on and on forever, doesn't repeat. And square root of 2, that sort of thing. Excellent. And what I mean by non-repeating is if you had like 0.33333 on and on forever, that actually is the fraction 1/3. So anything that ends up having this repeated units ends up being able to be written as a fraction. You could test it. It's cool. But just to keep going, to finish off our system, these rational numbers can break down even more. The next subset down would be our integers. And so integers are, for example, -3, -2, 0, 1, 2, 3. There are positive and negative whole values, no fraction-y decimals here. They all are rational because you could write them as -3/1, -2/1. You can write them as fractions, so they are underneath the umbrella of everything. But those are integers. And we go down one more subset, and we have our whole numbers, which start with the donut hole, which start with 0. And so they're just our positive whole, our positive non-zero, no, our positive numbers 0, 1, 2, 3, and so on. So just no negatives, non-negative. That's the word I was searching for. And then our last one are our natural numbers, or sometimes they call them our counting numbers, and they just start at 1, no 0 for them, and go on. And so there we go. So you see these numbers thrown about all the time, and so now you kind of have an idea of what they mean. So when we're talking about integers, positive and negative whole numbers. When we're talking about whole numbers, we're not allowing any negatives, but we will allow a 0, that sort of thing. So we will not be scared when we run across these numbers.